No. No,
it can be philosophical.
Yeah, it can be.
Doctor of
It
philosophy.
stands for Doctor of Philosophy. Yeah. So, yeah, it doesn't have to be scientific, and of course people do PhDs in the arts, so...
Yeah, I was just wondering if it was something, but you were sort of saying that you could use qualitative data in...
Absolutely, I think it's important to see quantitative and qualitative as equally valid. It's just that they have different methods behind them, do they not? You can't apply the same methods.
Are there PhDs that don't include logical argument? Because in my case,
mine contain no logic. No, that's not true. But yeah, absolutely. If it's you can't ignore logic, but it may be that logic is not your baseline. It may be that philosophy is your baseline, or political thinking, which is structured with some logical underpinning, but where the politics and the impact in the world is your baseline. So it depends what your impetus is and where you're trying to go. So in that sense, some writing may not end up being scientific and baseable on stats or logic purely, but it's got to be provable in the sense that it's referenceable. You can't be making grand claims that you can't show others have made in some format before and are based on some kind of reasoning, logic, etc., and that you're building on something.
Right, I mean, it's always some kind of argument, right, which has to be built on deduction and logic in some sense. So in some sense, there is a scientific underpinning, I think, in a way, or at least it's part of the thinking. I think that's innate into humans.
If you look at some artistic, we could go on, but it's some artistic.
There's a logical underpinning to science.
But imagine a lot of artistic work, literary or filmic or whatever, builds on metaphorical thinking, which has a different kind of logic imbued, and it's maybe 2 layers down. But the top layer of your argument may be based on metaphor, metonym.
Yeah, and I agree with that. I'm not disagreeing with that.
Yeah, so
I'm just talking about underneath that. As a computer scientist, for instance, I can make an algorithm that uses widgets. Whatever those widgets are, if that's art, or if that's pure logic science or whatever, it doesn't matter. The algorithm is still a logical algorithm that you build upon to get somewhere.
Sure. Yeah, I think this comes back, I'll shut up in a minute, but I think it comes back to something we raised in somebody's supervision today, that this is one of the reasons, the difference in the modality of what you're presenting if you're writing philosophy or literature or some kind of arts-based work, is the reason why in the arts and more artistically related practice-based work that you're doing, we say no more than 20% may have been published before, because the words themselves are what you're producing.
Right.
Whereas in computer science, so long as you can use the same research, but so long as you word it differently, that's fine, because it's not the words that are your product.
Yes.
So it's the same kind of issue, but it's too. Anyway, I'll shut up.
No, I think that's all very useful to draw out those distinctions.
The most important quality a piece of research can possess is thoroughness.
Yeah. So this is about, you don't have to use the formal methods. They could be qualitative, they could be quantitative, there could be a whole range of different methods that you use, and you have to use the methods that suit what you're trying to do. But whichever methods you use, you must apply them thoroughly and not half-heartedly. So you must analyze things completely and correctly, and just be convincing. To make convincing, in the end, to have a convincing conclusion. As we said, that you'll never reach a conclusion, but you've got to make one, you've got to have one. And it must be in some sense convincing that you've gone this far, and you've done this much, and it does stack up, it actually is a thorough piece of work. So it's not a question of answering 1,000 different questions, just 2 or 3, and answering them thoroughly, to leave no stone unturned in answering those particular questions, as opposed to being the smartest person in the world or anything like that. It's completely irrelevant.
This is a sort of finer point one. The interpretation of information is always affected by the means of collection, encoding, and representation.
This is one that's discussed.
Yeah, it's been done.
Read it again, because I've forgotten already.
Interpretation of information is always affected by the means of collection, encoding, and representation.
Okay, so there's collection, encoding, and representation. And one of those 3, if not all 3, will affect all of you, because you'll be collecting information. You'll be encoding it in some form, either to put in your work or to put in the computer, And again, you'll be representing it in your work, in your thesis, but also maybe inside a computer, in a 3D world or in a program.
Edward
or whatever.
Tufte showed us that you can,
So it's again,
Tufte, the famous, showed you can really represent information in completely misleading ways.
yes.
Yeah.
And what I'm trying to say there is it's very difficult not to. I mean, because there are all these biases, intentioned or unintentioned, and because you have to make choices about how you represent things and encode information. I'm thinking very much that the point is influenced by my own research in neural networks, where there's an analogue of the old saying garbage in, garbage out, which is that the way, crap encoding, rubbish results. If you don't encode the information in the appropriate, however you encode the inputs to the neural network, that will be at least as influential on the results as the neural network algorithm itself. Because there's a famous example of that from a military one, which is where they tried to use some form of pattern recognition to learn to recognise when there were certain targets in a terrain, tanks or something like that. And some of the images were taken with a bright sky, and others with a twilight or something. And the system simply learnt to recognise whether it was a bright sky or twilight, because that was the easiest way of telling them, because it happened to correlate with whether there were targets there, which they hadn't thought would happen. But it was just finding the easiest way of solving the problem. So the way they encoded the information left it wide open to come up with a completely daft result. And it's easy to do that.
The machines only fired at tanks and twilight.
Yes, exactly.
No, it's daylight, sorry.
As soon as it gets dark, it just starts firing.
Yeah.
That kind of thing. So obviously, that's a rather trivial example, but there are much more subtle examples that will be relevant to your own work about the choices you make in selecting information, collecting information, surveys, the statistics the measurements you choose to make, and precisely what you do with that information, and how you analyse it, how you encode it, and represent it, which will affect some of the conclusions that you reach along the way. And you need to be very sensitive to that fact. In other words, think, if I had done this differently, if I collected different data, if I'd collected more data, if I'd collected different measurements, which might also have been valid, could I have actually come up with a different result? Rather than, yes, they've got a good result, that must be true. Let's go quickly move on to the next thing. So at some point you have to step back and look at the whole design of everything and say, actually, there are possibilities that it could come out a different way. Next one.